transformation which maps z equal to 1 iota negative 1 onto w equal to iota 0 negative iota respectively. For this transformation, we also have to find the images of mod z less than equal to 1 and the concentric circles mod z equal to r, where r is strictly greater than 1. So first we have to find out the bilinear transformation for the given points. So the given points are z1 iota negative 1, which are transformed into the points w iota 0 negative iota respectively. So here we are going to use the cross ratio preservance. Now since the cross ratio is preserved under a bilinear transformation, so we have here w iota 0 negative iota, which is equal to z1 iota negative 1. So how to apply the cross ratio? So in the numerator we have w minus iota divided by then iota minus 0 into then 0 minus iota, that will be plus iota, divided by minus iota minus w. So this is how the circle is completed. Just take the difference of these two in the numerator, then the difference of these two in the denominator, then again the difference of these two in the numerator, and then back the difference of this minus iota and w in the denominator. Similarly, on the right hand side we have z minus 1 divided by 1 minus iota into iota plus 1 divided by minus 1 minus z. Then just we write here w minus iota divided by iota, and this is iota divided by, let's manage the signs of these two. So this becomes iota plus w, and this is equal to z minus 1 divided by 1 minus iota into iota plus 1 divided by 1 plus z. That negative sign cancelled out from both the denominators. So this implies this iota will go, and we get here w minus iota divided by iota plus w. This is equal to z minus 1. Let's take this first, 1 plus z into iota plus 1 divided by 1 minus iota. Let's rationalize this. So this is 1 plus iota divided by 1 plus iota. So in the numerator we have 1 plus iota whole square, that is a square plus b square plus twice ab. So this is 1 and this is negative 1, and then 2 iota remains, and in the denominator we have a minus b and a plus b, that is equal to a square minus b square. So that becomes 1 minus minus 1, which is 2. So we have 2 in the denominator and this 2 will go. So this implies w minus iota divided by iota plus w equal to iota into z minus 1 divided by 1 plus z. Fine? Okay. Now to apply the comparator and dividend rule over here, let's take this positive part in the numerator. For that, just take the reciprocal of these two sides. So we get iota plus w divided by w minus iota, and this is 1 plus z divided by iota into z minus 1 to avoid the confusions. Now let's apply the comparator and dividend rule over here. So numerator is added with the denominator, and then the denominator is subtracted from the numerator. Numerator is added to the denominator, and then the denominator is subtracted from the numerator. Fine. So this implies this iota and minus iota cancelled out. So we have 2w, and here w and w cancelled out. So we have 2 iota in the denominator. This is equal to, let's take z common from here. So this is 1 plus iota into z, and here we have 1 minus iota divided by, this is 1 minus iota into z and plus 1 plus iota. Very fine. So this 2 will go, and we have w equal to iota times this. Okay, let's take 1 plus iota common from the numerator. So we have z plus 1 minus iota divided by 1 plus iota. We have taken 1 plus iota common from the numerator, and similarly let's take 1 minus iota common from the denominator, so that this z left alone over here. So this is 1 plus iota divided by 1 minus iota. Now what is the value for 1 minus iota over 1 plus iota? Just rationalize this separately. So the value for 1 minus iota over 1 plus iota. If I rationalize this, what I get? This is 1 minus iota divided by 1 minus iota. So this is 1 minus iota whole square, which is a square plus b square minus twice ab, divided by a square minus b square, which is 2. So this is cancelled out. So we have this as negative iota. This is the value for 1 minus iota divided by 1 plus iota. And then let's calculate 1 plus iota divided by 1 minus iota. Again, let's rationalize this. So this is 1 plus iota divided by 1 minus iota, and this is 1 plus iota divided by 1 plus iota. So this is 1 plus iota whole square, which is a square plus b square plus twice ab divided by 2, and this cancelled out. So we have this to be as 2 gets cancelled, so we have iota over here. So the value for this is iota. So let me write the values for this, and 1 plus iota divided by 1 minus iota is also written to be as iota, right? So this becomes, this is iota and this is iota, which is iota square. So this implies w is equal to, this is iota square, and for the numerator we have z plus 1 minus iota over 1 plus iota is negative iota, and in the denominator we have z plus 1 plus iota over 1 minus iota, that is iota, right? So this is z plus iota in the denominator. So this is equal to, this is negative 1, and this is z minus iota over z plus iota, which can also be written as iota minus z divided by iota plus z. So this is your required bilinear transformations for the given transformed point. And now to calculate the inverse transformation. So the inverse transformation is, we just have to write the value of z from this transformation in terms of w. So when you cross multiply, then you will get that z is equal to iota into 1 minus w divided by 1 plus w. Please do this yourself. And then first part is to find out the images of mod z less than equal to 1 under that inverse transformation. So just put the value of z over here, which we have just calculated as the inverse transformation. Before putting the value, we know that mod of z square is z into z bar, the conjugate of z, right? So let's first square both the sides, and then writing this as z into z bar less than equal to 1. And now let's put the value of z over here. So z is iota 1 minus w divided by 1 plus w, and here z bar is, this is negative iota, into 1 minus w bar divided by 1 plus w bar. This is less than equal to 1. Iota square is negative 1, so negative 1 into negative 1 is 1. So we have 1 minus w divided by 1 plus w into 1 minus w bar divided by 1 plus w bar less than equal to 1. Let's multiply the numerators. So we get 1 minus w minus w bar plus w into w bar. Let's take the denominator to the other sides and then multiplying the denominators also. So we get 1 plus w plus w bar plus w into w bar. So this 1 is cancelled out, this w bar is cancelled out. So we get from here, let's take this negative w to the other side, we get 2w, and taking this minus w bar also to the other side, we get this then 2w bar, and this is greater than equal to 0, which implies w plus w bar is greater than equal to 0. Now as we know that w is equal to u plus iota v, and w bar is equal to u minus iota v. If I add these two, I get this to be as twice of u greater than equal to 0, which implies u is greater than equal to 0. And this u is nothing but the real part of w, right? So I can write this as the real part of w is greater than equal to 0. So the interior of the circle mod z equal to 1 is transformed into the, yes, real part of w greater than equal to 0 means u is positive, yes, and where u is positive? In this part and also in this lower part. Thus, the interior of the circle is transformed into the right half of the w plane, right? Okay, let's move on to the next part. And the second part is the concentric circles where r is strictly positive. Yes? So mod z equal to r is transformed into, just put the value of z over here, the inverse transformation. But before that, let's square both the sides. And this is z into z bar is equal to r square. So we have z as iota into 1 minus w divided by 1 plus w, and z bar is negative iota into 1 minus w bar divided by 1 plus w bar. This is equal to r square. This becomes positive 1, and then multiplying the numerators and the denominators, we get 1 minus w minus w bar plus w into w bar. So this is equal to r square times, multiplying the denominators, we get 1 plus w bar plus w into w bar. Let's take w bar common. So this is 1 minus r square into w bar, and then taking this sum of w bar common, here just take negative sign outside, and this will gives us minus of 1 plus r square into w plus w bar. Please check this. And then the remaining terms is, okay, this is 1 minus r square, that is equal to 0. Yes, okay. Now as w is equal to u plus iota v and w bar is equal to u minus iota v, so what is the product of w bar? 1 minus r square into, yes. If I multiply these two, I get u square plus v square. So here I'm writing u square plus v square minus, this is 1 plus r square, and if I add these two, I get twice of u plus 1 minus r square equal to 0. And then let's take 1 minus r square common. So I get u square plus v square minus twice of u. This is 1 plus r square divided by 1 minus r square plus 1 equal to 0. Then in the next step, I'm considering this term and this term to make the perfect square. So for that I require 1 plus r square over 1 minus r square, the whole square extra. So let's add and subtract 1 plus r square over 1 minus r square whole square, because I need to subtract this term also. So let me write this term to the other side. So this is 1 plus r square over 1 minus r square whole square. Yes, and then I get, if I consider this first term, second term and third term, so from here I get the formula as a square plus b square minus twice ab, which will a minus b whole square, right? So u minus 1 plus r square over 1 minus r square whole square. And then here I'm having v square remaining, and let's take this constant term to the other side. So this is plus v square equal to 1 plus r square over 1 minus r square because it is a whole square, so taking square and square separately in the numerator and denominator, and this is minus 1. So this is equal to, if you solve this right hand side, you get this to be as 4r square divided by 1 minus r square whole square, and the left hand side as it is. If I consider this to be my real part and this to be as imaginary part, what I get, can I write this as mod of u minus 1 plus r square over 1 minus r square plus iota v. Can I write like this? And also the square, because of the square root. Can I write it like this? Yes? Can I write like this? Okay. Why? Because as we understand that u plus iota v mod is equal to what? It is u square plus v square under the root. If I take the square, so I am having the right hand side as u square plus v square only. That is what I have done over here. If this u is a real part and v is an imaginary part, if you match, so you understand that this left hand side can be written as this. I hope it's very clear now. Thank you so much. Okay, here u plus iota v is w. So this is w minus 1 plus r square over 1 minus r square mod square is equal to 4r square divided by 1 minus r square whole square. And if I take the square root on both the sides, then the square vanishes from the denominator, from the numerator also. And here I'm having, instead of 4 as 2, because 4 is 2 square. Yes, so this is nothing but a circle in the w plane with center 1 plus r square over 1 minus r square and the radius 2r divided by 1 minus r square. So this is your circle in the w plane. So the concentric circles mod z equal to r is transformed into this circle in the w plane. Yes? Okay, thank you so much. God bless.